Okay, Hibernate Search. I should first introduce myself. My name is Hardy. I'm a member of the Hibernate team for quite some years now. And I actually started with Hibernate Search. That was one of my first projects I was working on. And nowadays I'm working more with bean validation. So I'm the project lead of Hibernate Bean Validation, or Hibernate Validator as it's called. And I'm also in the expert group for bean validation specification. Just to kind of get a feel, anyone using already Hibernate Search? Ah, okay, one. Two maybe. So that's good. Anyone using Hibernate? And okay, so everyone knows about Hibernate. That's good. So I don't have to kind of dig too deep. What are we going to talk about? I will start with what is freetext search, explaining a little bit the concept behind freetext search. And I'm trying to kind of put this under some sort of imaginary application you are supposed to develop, which is a DVD shop. So I get to that in a second. I will then kind of give you the basics of Hibernate Search. What is it about? How does it work at the basic level? And then once we've covered that, we kind of dive a little bit deeper and talk about really the interesting bits about freetext search, which is analyzers, filters, faceting, things which once you kind of get more advanced with your search applications, you probably want to build in your applications. The idea, the motivation. Let's just imagine here for a sec, most of us are developers, right? So we are kind of writing software for a living. So say I'm your boss and I'm coming to you and say, I have a customer who wants to have a DVD shop online. He's selling DVDs and he wants to put them online. You can go there and you can search for a title or a name of an actor, and you get a list of these DVDs and you can click on it and buy it, right? It's a very simple application. I guess all of you kind of start already thinking, oh, what do I use? And each developer has some certain tools. He kind of goes, oh, you know, if I have to have this task, I use this tool. No, it's like this kind of thing. So for example, a build tool is very, everyone wants to have a build tool if you start with a project. So Maven, Cradle, who cares? Doesn't matter. Your application, your DVD shop has to run in a container. Maybe you want a Tomcat. Maybe you go JBoss application server. You have a web interface. You need some model view controller framework, struts, rich faces, you name it. It gets a little bit more interesting. Domain model. You probably have some sort of model of your problem. I would assume you have some sort of film entity, some sort of actor entity. You maybe want to use Hibernate to kind of make it easier to kind of map into the relational database, to kind of create films, to kind of retrieve them. And now comes the big question: search. So the customer is saying, look, your shop or your application should work like Google. You just type something and maybe there's auto-suggest, or if you mistype something, you still get results. All these nice little things every one of us is used to. I mean, everyone knows how Google works, how the big search engines works. People want this type of search behavior in their little applications. They don't want... So basically, when it comes to research, you maybe sit there and go, scratch your head, what do I use? What tools do I use there? Because that's not so common anymore. Now you're kind of maybe leaving your comfort zone. And the trivial approach, I mean, everyone go, we have a relational database. We write like queries. That's how it works in a relational database. Just a very vague example, you kind of use in SQL, you use the % sign as a wildcard character. And as example, if you would like to search on title and actor at the same time, you would kind of create some sort of query string with the wildcard characters around and stick it into a very long string, which is kind of a select statement joining film and actor. It's not really important, but I guess everyone can see that this is quite ugly code. Think about maintenance. It's all string concatenation. The IDE doesn't help you much if things in the domain model change. Like you have to make sure that your queries change. You probably have multiple queries, so you have a whole bunch of these strings flying around. It just doesn't scale really well. And there's a whole bunch of other problems you can actually not easily solve with SQL. Let's talk about the wildcard search. Yes, database or SQL has wildcard search, the % sign, but often doesn't perform that well, especially if you start using the wildcard character at the beginning of your search term. If you have a big database with a lot of data, performance will drop quite rapidly. That said, most database vendors nowadays have some sort of free text search engine or something built in their database, which you can configure and use. The problem here is that every vendor does something else, so it's very specific to the database you're using. You're not having an application anymore which runs against any database, basically. Another thing you cannot do with SQL is approximation. Say someone wants to search something, Hibernate, but he consistently just does not get the eye and types it like this. In SQL, there's no way you find it. Again, Google and other big search engines basically show it's possible, and this is called proximity search, approximation. And proximity is another thing. So imagine you have a very long document, and your search words are Java and persistence. So it actually matters if in one document the first word is Java and the last one is persistent, or in another document it's Java persistent right next to each other. Often what you want is that this document or this text will be kind of returned higher in your result list because it's more relevant. Again, pretty much not possible in SQL. Result scoring, you kind of want to kind of boost certain values or change the way the results are returned. In SQL, you basically just have an order by clause, and that's it. You want to do much more. And then we have multi-column search. Just imagine you want to search across all your database columns, all your actor and film columns. Thinking back to the strings, I think you can see that it gets quite ugly very quickly. So really, SQL feels, in this case, if you have this kind of requirements, feels like putting antlers on this little dog. It just doesn't fit together. You're forcing a tool onto your problem which is not made for the job. What you really are looking for is something like this, something where where the antlers, you want a powerful tool which kind of delivers what you're looking for, and that's free text search. A committed developer as you are, you kind of localized your problem, you kind of go, okay, SQL is not good, I still have the problem to implement search. What do? You go out to the internet, you read about free text search, and very quickly you come across Lucene. Lucene is an Apache, an open source project from Apache. It's one of the top 10 projects in Apache, and it is a powerful implementation of a free text search engine. Effectively, it's what Google does, Bing, or whatever search engine. It's the same ideas behind it. So the next step is like, oh, now I found my free text search library. What's next? I have to kind of plug it into my existing application. And very quickly, you will hit 3 different problems. And that's structural mismatch, retrieval mismatch, and the synchronization mismatch. And I'm kind of very quickly try to explain to you what this is about. The structural mismatch is quite easy to understand. In your application, you're working with entities, right? You have a film, and the film has a one-to-many relationship to actors, and you have this association and these entities in memory. At the same time, Lucene is a completely different API, completely different concepts. In Lucene, everything works around what is called a Lucene document, which is a fancy map. It's basically just key-value pairs. And what Lucene does is like you throw a whole bunch of documents to it. It kind of iterates over the documents and creates something which is called an inverted index. And whenever you do a search, Lucene goes to the inverted index, finds IDs of the documents which are matching the search query, and returns you documents, Lucene documents. So here you have a problem. It's like in your application you're having entities, but Lucene wants that you're using documents. So at some stage you have to write some boilerplate code which converts from left to right and vice versa. That's a retrieval mismatch. Again, you do a search in Lucene and you're getting Lucene documents back. What do? I mean, you still want to work then again with entities because that's what we want to work with domain classes. And one simple way would be, okay, I have the Lucene document, just pick out the values and instantiate the entity classes again. But hang on, now I don't have a Hibernate session. Now I created these entities, but they have no connection to the database. So I would have to reattach them or do something to kind of make them managed object in the Hibernate sense, which is also not what you want. You want to execute a search, get the result back, and then being able to maybe modify a film or kind of, and then write it by just kind of saving the session or closing the session, writing changes back to the database. And last but not least, the synchronization mismatch. Say there's again, the DVD online shop example. Say there's a shop owner who kind of adds new films. And he kind of creates these new films via object relational mapping, via Hibernate. They go into the database. That's great. But without the right hooks, the Lucene search index is not going to be updated. So even though the entities or the data exists in the database, it's still not searchable. So you need some sort of hook which kind of also makes sure that whenever something changes in the database, in my entities, then something has to happen with the index. It has to be kept in sync. So these are the problems: the retrieval mismatch, the structural mismatch, synchronization mismatch. And what we are saying as from Hibernate, just don't do it. You're spending a lot of time and effort writing a lot of boilerplate code to just overcome these problems. You haven't solved anything yet. You're just writing boilerplate code to kind of get it going at all. And this is exactly where Hibernate Search comes in. Hibernate Search tries to kind of close this gap for you. It kind of takes Lucene, it takes Hibernate, and tries to integrate them as seamlessly as possible. So that you can basically use it with hopefully just a few annotations and writing some SQL or some Lucene queries. So that's the idea. It takes all this boilerplate code, all these synchronization problems, all this mapping domain model to Lucene document. All this is supposed to be hidden from you. How does it work? So now we kind of get into the basics very quickly how Hibernate Search works. The first thing is you need Hibernate Search as a dependency. You put it into your application together with all the other jar files it needs. And then to enable it, you just have to register an event listener. The good thing is that Hibernate Core or Hibernate OGM, the main Hibernate project, has some code built in which automatically detects Hibernate Search. So if you throw in the libraries, Hibernate Search, into an existing Hibernate application, it goes, hang on, Hibernate Search is on the class path. Let's enable it. So you don't even have to think about that. And then there's a whole bunch of configuration options for Hibernate Search, where you can fine-tune and tweak Hibernate Search, which all of them have reasonable defaults, so you don't have to do anything except maybe specify a place on your file system where you want to keep the Lucene indexes. That's pretty much to start with. Later on, you can also think about maybe you want to cluster your index or something like this, but out of the box, you just say, okay, put it on this place on the file system. And now the interesting part. So let's take a simple class, a film entity, which has our JPA annotations, entity, @ID. We have some other attributes, summary and rating. And we have a one-to-many relationship to actor. Right, so that's standard JPA, standard Hibernate. What's the thing you have to do? First, you have to tell Hibernate Search which are the entities I want to search on. I mean, somehow we have to know for which entities we want to create a Lucene index. And you do that by just adding @index to this annotation, to this class. The next thing is somehow you have to tell Hibernate Search which are the fields you want to search on. Oh, okay, that's the summary field and the rating field. And you want to search on actors, which is another annotation called index embedded. Index embedded is a quite interesting thing. Lucene doesn't have a concept of join. Lucene, as a search engine, does not know the concept of association. It does not know that there is a film which has an association to a bunch of actors. It's a flat structure. So what has to happen is whenever you create a Lucene index or Lucene document, we have to make sure that all the information you want to search on is embedded in this one single document. So effectively, at the time an instance of film gets indexed, we denormalize and kind of put all the data we need into this Lucene document. It doesn't really hurt, so it's not like your database is still the central point, which is perfectly normalized. But in this case, we have to denormalize it for the Lucene index. Okay, so you created these, maybe go on, you created these annotations, you have the jar file in your application. So once you have that, and now you start creating entities or films, and you save them. Hibernate Search will automatically create the Lucene index, and you can write your search queries. And there are several ways to do that. I hope you guys can read that. Basically, what the key thing is to get first a query builder. And you basically say, you start with a session which gives you a search factory, and then you go, give me a query builder for the entity film. And then, using this query builder, we have some sort of fluent API, which is quite popular at the moment. So we have a query builder. I want to do a keyword search. You're kind of listing the fields. I want to search on the field summary. I want to search on the field actors.name. And that's where index embedded comes in. Actors.name is a concatenation of the property path. And matching, so my search term is the godfather. And then I say create query, which returns a Lucene query. Using this Lucene query, I can create something what we call a fulltext query. That's now a Hibernate class, which is actually a subclass of a Hibernate query, which means you have now the full API of Hibernate. Now we are basically getting back into the Hibernate world. And you go query get result list, and you're getting back a list of actually not films, a list of film instances which are managed by Hibernate, so they are connected to the database, there's an open session, and all of the film instances are matching your search criteria as a godfather. Does that make sense? There's an alternative. If you don't like the Fluent API, you can write native Lucene queries, which is, Lucene has something like, they call things like a multi-field query parser, and then you're parsing in again the search fields and the search query. And once you have a Lucene query again, from then onwards, it's exactly the same thing again. It's a matter of taste what you like. A lot of people like the idea that we have this query DSL, which kind of completely abstracts away Lucene, so Lucene is not visible at all anymore. And then others like more the Lucene approach, where you write your Lucene queries in Lucene and then kind of plugs them into Hibernate or into the full text query. Right, so far so good. What we have now is a little bit something which looks like this. You have Hibernate OGM and Hibernate Search running as one application. And we have access to Hibernate writes to the database and reads to the database. And Hibernate Search makes sure that the Lucene index stays in sync at the same time. You can actually, at the same machine, running against the same database and the same Lucene index, have another application. The database is protected using transactions. The same thing with the Lucene directory, and Lucene has a locking mechanism itself, so the index cannot get corrupted. It's thread safe. So that's a nice thing. That are the basics of Hibernate Search, and now I think we are ready to dive into a little bit more advanced concepts. Any questions so far? Huh? Analyzers. Analyzers are really the nuts and bolts of any free text search. No, it's not only Lucene, I guess any, like Google, any free text search engine at some stage has to take the text and chunk it up into words and apply operations on it to kind of then take these search terms into the inverted index to make them searchable. In Lucene, these classes are literally called analyzers, which kind of do the splitting up into words, and then what normally happens, things like word stemming. You want to, like a plural S in English, like car and cars. You often want to split off the S so that it does not matter anymore if you search for car or cars. Synonym search, when you're indexing car, maybe you also want to index at the same time automobile. So if it wouldn't matter anymore if someone searches for car or automobile. So these kind of things, that's happening at the analyzing step. And I thought I have a little demo to kind of visualize a little bit what analyzing is about. So welcome to GDD Krakow. So welcome would kind of go through this analyzer, and you probably would kind of cut off the E from the stemmer, and often you lowercase your words, so that it doesn't really matter in which kind of uppercase or lowercase searches. Then maybe you want to insert a synonym, hi, I don't know. Another thing which happens at the analyzing step is filling words are just kind of getting thrown out like to, the, These are words no one wants to search on, so they normally just get discarded at the analyzing step. JDD kind of gets indexed here, Krakow. So now we have a document which can be sent off to Lucene to be indexed, and all these 4 terms are then searchable via your search API. And to enable that in Hibernate Search, we kind of thought we'd make it really easy, and we call it like Analyzer Lego. And it's again annotation driven. We have something annotation which is called Analyzer Dev. You give it a name like Custom Analyzer, My Analyzer, and then it's really like like building Legos. The first thing which you always need is a tokenizer, and I recommend standard tokenizer. A tokenizer is the thing which kind of breaks the words up into tokens. That's the easy step. That's the first step you have to do anyway. And then you kind of chain a whole set of filters. So like in this case, a lowercase filter. That's kind of making sure that whatever gets indexed gets first lowercase, and we only always search lowercase. Then the stemming I mentioned, a snowball porter filter factory. That's a class which basically does stemming according to your language. So this snowball stemmer comes for all sorts of languages, English, German, Swedish, you name it. So you're kind of just defining, this is the analyzer I want to use for my project or for one particular field I want to search on. And then you kind of, where you have your field you want to index, you kind of just add analyzer, and you're kind of using the name you kind of gave the analyzer in the definition. So the custom analyzer is kind of the thing which matches the definition to where you actually want to use it. Otherwise, I mean, it's really like completely annotation driven. So you kind of just configure it in your classes, or you don't have to write actual code or plug it together in a helper class or something like this. Another very powerful concept of Hibernate Search are filters. Or not of Hibernate Search, of Lucene. And the way it works is you have your documents, say 8 documents, and you do a search, and as a raw result of your search, you're having 6 documents matching, like 1, 2, 4, 5, 6, and 8. And now what you can do is you can add in additional filters to your search, which are kind of blocking out certain results from your search result. And again, you can change them so that in the end, maybe only document 4 and 6 are returned. One reason to do that is performance. Filters are very performant compared to the actual search. And then depending on the use case, filters are easier to use, or kind of they make a little bit more sense. Let's take an example. Again, the same principle, we use annotations to kind of make it easy to configure these filters. In this case, I configure 2 filters using the full text filter definition annotation. And again, I have to give each filter definition a name. That's the thing how I identify it. And then I have to specify an implementation class. So what the filter does, there I have to write code. So I have to implement rating filter or security filter factory. And now it's actually quite easy to enable it. You write your query. You again use the full text query to create the query, and then you say full text query enable full text filter rating, enable full text filter security, and then this filtering mechanism comes in. If you think about security, this is actually one of the things where you go, that's right. You don't want to bake security into your search query. That kind of doesn't make sense. Security is more like an orthogonal concept. It's like, I want people to search, but if I'm not 18, I don't get certain search results. So security is something you go, yeah, hang on, that's something I would like to use a filter on, maybe. Maybe rating the same. You can go either way. I could write the same query and baking basically rating and security into my Lucene query. But filters are first more performant, and in certain use cases, they just feel more natural. Projection. That's another powerful feature in Hibernate Search. So far what happened was I write my query, Hibernate Search goes to Lucene, retrieves the documents which are matching your query, And what Hibernate Search then normally does is like it takes the Lucene document also contains Hibernate or the entity ID for the relational database. So Hibernate Search goes, hang on, I have to get these entities now from the database so that I can give them to you as managed objects, so that you then can be working in your Hibernate session in the Hibernate or JPA world. Which is great. In some cases, that's not really what you want, what you need. A good example is the first result page. So say you're searching for the Godfather in your application, and then you get your result list. There, often, all you need is the name maybe of the movie. You need a link to be able to actually click through to it, and that's about it. And then once you click on the movie, then often you have to really go to the database and pull all the information out, like the summary, the title, the actors, the rating, all these kind of things. But for this initial screen where you kind of just have, here are my search results ranked after relevancy, you don't need that. And that's where projection comes in. Projection is a way in Hibernate Search to say, hang on, I actually don't need managed objects. I can save the round trip to the database. Just give me the values out of the index. And that looks, again, it looks like this. You kind of create your full text query, which is all, as we've seen now many times. And then you say query set projection. So now you're saying, I don't want a query which returns managed objects. I want a query which kind of gives me the values out of the Lucene index. And with that projection, you're also saying which kind of fields you want to get out of the index. And you go query.list to get the objects back or the data back. And now the big difference to the Hibernate way or to the managed object way is like, now I'm getting back an object array. So now I'm working with the raw data, which is often enough for depending on what you want to do or what you want to display. But you're not having managed objects anymore. But it's probably enough to kind of render the first result page. Faceting. Anyone knows what faceting is? Anyone worked with faceting? So this is a definition from Wikipedia. I actually skip that and show you right away a picture. A picture is, in this case, really much easier to understand than words. Faceting is you're executing a search, and like Amazon or shop sites, everyone has faceting nowadays. So you have your main search, but at the same time, there's a search going on that's saying, okay, someone is searching for Hibernate Search the book. What other books do we have in programming, computers? So now they're looking in the facet, computers and internet. And then there might be also, now there's only one paperback, but there could be hardcover paperback. So facets are basically allowing the user, you do a search, and I'm kind of doing sub-searches already for you to allow you to kind of narrow down your search results and kind of dive into the results. So we look at the search results and kind of already categorize them. And that's called faceting. And again, I mean, I think everyone has already seen these kind of search applications around. I mean, as I say, like most shops nowadays have this kind of search functionality. How does it work? How can you enable that? Again, you need a query builder from Hibernate Search, and then you're creating something which is called a facet request. You give it a name. We have to always give things a name so that we can identify it. And then you say, I want to have a facet on the genre of the films. So if I do a search, I get basically a facet of the different, like I search for an actor, Al Pacino, and then on the side I want to have action, drama, I don't know, whatever type of movies you had. And then I kind of say, does this facet include 0 counts or not? So if there's like in this other example from Amazon could choose to say there are 5 paperbacks and 0 hardcovers. But often the 0 count is not relevant, so you can kind of say that you want to exclude that. You also say how many facets maximum. So you might have hundreds of facets, so you say maybe 3 facets. And then you create this faceting request. And in this case, you kind of, when you have your full text query, you get something which is called the Facet Manager. you say enable faceting, and you're passing in the facet you created, and then you kind of return full-text re-release. You're kind of getting your list of managed films back, or film instances. And then at the same time, the Facet Manager kind of does its thing. So once you called list, and you have your films back, you then can say, Facet Manager, give me the facets for genre, or for whatever facets you kind of defined. And then again, you have the facets, you render them, you display the way you want to. Any questions about faceting, analyzing, filters? So these are really the things, once you get really into implementing an application which needs free text search, these are the things which are actually also most interesting to work with, because that's where the fun is. Which analyzer do I use? How do I put it together? Should I use a filter or should I use a query?
I was just wondering, how do you handle, in your example, you had Krakow with a special O.
Yeah.
How do you handle those kind of situations with searching and analyzing?
You basically, Lucene is UTF-8 or handles different character encodings quite well. So that's kind of part of Java anyway, being able to handle all different character encodings. And then there's, like, for example, stemming. It's specific to the language, so that will take care of things. So if you stick to one language, that's quite easy. One thing which is maybe, we talked about this yesterday with someone. Say you want to enable search for two different locales, like for English speakers and for people here in Poland. So at this stage, you want to maybe index in two different languages so that you kind of have alternate spellings. And there you would kind of, you probably would write your own custom analyzer and combine whatever the Polish analyzer does and the English analyzer. You probably have to write some custom code. But that's basically the step where, okay, now I have to write my own analyzer or filter or whatever. More questions? And again, faceting is relatively new. It's actually, more and more people ask about this one. And users or customers basically ask for this kind of search functionality. They want to have the full Google or the full, like, my search should work like Amazon. Now, some quick words about clustering. That's also, we kind of try to make it easy to scale your application. So far, we had Hibernate and Hibernate Search running on one machine, talking to Lucene Index and the database. What we can do is there's one clustering solution we offer is where all index updates. So say you're creating or editing your film or changing something in your film. Then this change event will be put on a JMS queue, which will be picked up by a master. The master takes up this indexing request and kind of updates the master index at the bottom right. And then at regular intervals, all the slaves, they get a copy of this master and search in this copy. So each slave searches in a local copy and does only searches, which makes it faster. You can have many slaves, do round robin or whatever between them. And then all the works, actually indexing work, is offloaded in a master or in a, yeah. Obviously, the side effect here is not in a single application. You kind of make your change, you persist it, and it's directly searchable. Here you have a delay. So, but again, like a lot of people say, that's fine if I kind of just re-index or update once over midnight. That's fine. It depends on the application. If you want to have the search results searchable right away, or if it's okay to have a certain delay. And even more, I just kind of touched already clustering. The latest release of Hibernate Search 4.2, it has something which is called spatial queries, which allows you to do location-based search. So you can, in your entities, you can, for example, have two fields, longitude, latitude, which are getting indexed. And then you can do things like, my location is Krakow, show me, or a Galaxy Hotel, whatever, and show me the nearest coffee shops or something. Provided you have the right data in your domain model and you have all the latitude, longitude values, you can do what's called a spatial query. So what are the closest shops or the closest coffee shops around me? I don't have an example for that. I don't think that's really, No, I don't want to really show more code, but it's exactly, we're sticking to the same principle here. We have spatial queries, you add some additional annotations like longitude, latitude. You have to tell us where are the coordinates. And then we have Fluent API again, similar to faceting, where you go, okay, here's your center of your search, maximum radius 5 kilometers, show me everything which matches this center point and this radius, and any other search criteria you're sticking in. Another extension, also just new in the latest Hibernate Search release, is Apache Tika. Anyone worked with Tika before? No? It's another Apache project, and it's basically purely centered around text extraction. That's also common use because a lot of people have the actual text they want to index in, say, PDF documents. And they're still kind of using Hibernate or have an application, but somewhere they have maybe just the file path to the PDF in the entity or in the relational database, and then the PDFs are kind of offloaded or somewhere on the file system. And they go, I want to be able to search in my PDF documents. With the Tika integration, you basically there are multiple ways of doing it, but one is if your entity contains the path to the PDF document or MP3, you can index MP3s even and get the metadata out of MP3s. So you can build your own MP3 library or something. So what happens is like Hibernate Search will kind of go out and kind of takes the file path, use Tika to extract the words from the document, index them, and then off we go into the normal Hibernate Search paradigm. It's quite nice, as I say, like Tika has filters or plugins for all sorts of document formats. Word, Excel, PDF, MP3, OGG, everything. So if you have a need for kind of getting meta information out of that, Tika is a good place to look. Another little thing you can do is conditional indexing. So far what I've explained was I creating or modifying a film instance and I save it and the index gets updated. But some people asked us for, hang on, depending on a certain status, take a blog system. Say you are blogging and you have this thing where you can actually create your blog but not publish it. So people said, we have this situation and we actually only want this to be indexed if the blog is published. If it's not published, don't index. So we have this conditional indexing where you can basically implement an interceptor and you're checking your entity. Oh, hang on, this blog entry is not indexed, is not published. Oh, okay, let's not update the Lucene index. To sum this up in very, very short summaries, Hibernate Search is full text search without the hassle. We kind of really tried hard to people want free text search. They see Lucene is a great library for doing that. There are a lot of problems if you want to do that right. There's also things like we haven't touched optimization. Lucene has this thing that in regular intervals you should actually optimize the index. Hibernate Search takes care of this as well. So we really tried hard to make the integration as seamlessly as possible and as easy as possible and have this thing, okay, you configure mainly by using annotations, and then often there is some sort of Fluent API to use this feature within your search. And like faceting, filtering, analyzers, all these things. That's exactly annotate, Fluent API, here's your result. More info you can find obviously on the project homepage, search.hibernate.org, there's more information. A great book Emmanuel has written that is Hibernate Search in Action. If you want to know more, read the book. If you want to get into the concepts of free text search, I highly recommend reading Apache Lucene. It's of course specific to an API, but you also learn just the core about free text search, inverted indexes, indices, and all these kind of things. If you want to follow us in relation to is our blog where we announce releases and tips and tricks. And you can always shoot me an email to get more information. And now is some time for more questions. So, yeah? Yeah, absolutely. Come again? Right now it only works with Hibernate, but we extracted the part actually, the part which is Hibernate Search specific is in a separate module. So if, in theory, if another provider would come along now and go, we want to use it, it's all extracted out in interfaces. They could implement that. We obviously are interested in doing it with Hibernate OGM. Yeah. I'm not quite sure. Okay, I get it now. There are two things. Lucene does not care. The Lucene documents don't have to be uniform. So you could index your films, and now you add a new film. Like you have summary and rating, and now you're also adding customer comment or something like this. You could kind of just continue adding this field and continue using the same index, and from that point onwards, what would happen is like the new films, they have the comment and they would be searchable. Whereas if there are old films which they don't have the comment there, so it kind of exists in both worlds. But what you want to do in this case really is there's a programmatic API which allows you purge index, so throw away everything, and re-index from scratch. So that's what you would do if you make this change. But in theory, the application is not breaking by having this old index and adding new fields. It's just, you have not the full, not everything indexed really. You know what I'm saying? Right. I mean, right. So if you're making changes or redeployments where actually the index changes or the things you're searching on, then you have to kind of rebuild the index. And as I said, there's a programmatic API. There's also something which is called the mass indexer, which is a heavily parallelized API which allows you via multiple threads to re-index your full database as fast as possible. And that's what you do. If you go to the forum, a lot of people come and report sometimes. It heavily depends on the type of entity, the amount of association on your machine, how much memory you have. Lucene is very memory intensive, so you need a beefy machine with a lot of main memory. Helps. It depends a lot on your configuration, depending on how much you index. There's something which is a buffer size in Lucene, how much kind of gets buffered before it gets written to the index. All these things can influence how fast it goes. So it's hard to give a generic answer. Yeah? Yeah, I don't have this in this slide. So there are two things you can do. First is the default, if you search, is by relevancy. So whatever Lucene kind of thinks is relevant. But then you can add additional sort fields. You can, for example, discard relevancy and say sort by first name alphabetically, or sort by any other field. Another thing which is relevant and kind of touches your thing, certain fields are sometimes more valuable. Like if you have title and summary. A hit in title is maybe more relevant than a hit in summary. In this case, there is something which is called boost in Lucene. So you can boost a certain field. So if you have a match in this field, it's more relevant than a match in another field. And there's an annotation called @boost, which you can use in Hibernate Search to say boost 2.0 on field on title, which means if I have a match on titles, it's 2 times more relevant than a match on the other fields. So that's the other part of the answer. So there are both things. You can sort on different things, but you can also make sure that certain fields are more relevant by configuration. Okay, more questions or? Yeah.
Okay, I have a question about the performance gain in the example you described at the beginning. So when we are using SQL, right, and we are using like with the wildcard at the beginning, right? It's very slow. We know that. And what can be the performance gain when we use this Hibernate Lucene Search?
To be honest, it's hard to give like exact percentages or factors, but we've heard there's really like a factor of performance gain. It's like it gets 10 times faster. It's hard to tell. It really depends a lot. If I throw out a number, it's like it's really you would have to test yourself, and it really depends also on your environment and how it's set up. Also remember, performance is one issue, like SQL versus a free-text search engine. The other issue is that a lot of the things we kind of discussed now, you can't even do in SQL. It's like you can't do proximity search unless you're kind of using some vendor-specific plugins for your database. But it's hard to put a factor or like a number onto these things. Any more questions? I think we're running out of time now, otherwise. All right.
I'm afraid we don't have time for any more questions.
Okay, great. So that's it.
Thank you very much for your presentation.
Thank you.
So that was our last lecture. Those of you who have any questions or concerns and didn't have a chance to ask about it, just please stay in this room. We're gonna have a small discussion panel.
Naprawdę zachęcam do tego, żeby Państwo zostali, dlatego że to może być bardzo ważne 10 minut. Także jeżeli ktoś naprawdę bardzo się nie spieszy, proszę zostańcie. Chciałbym, żebyśmy sobie wspólnie odpowiedzieli na jedno proste pytanie. Po co tutaj dzisiaj przyszliśmy? Ktoś wie, po co tutaj się dzisiaj pojawił? Po nagrody, okej, ale to chyba nie będzie teraz jeszcze losowania, także Marku, niestety nagrody nie dostaniesz, ale możesz dostać dużo więcej. Czy tak ja się na tym zastanawiałem, wydaje mi się, że ja bym chciał, żeby mnie zainspirowano, że szukam tutaj odpowiedzi na różne pytania, które mam w pracy i znajduję je albo wśród dostojnych prezentacji, albo wśród rozmowy z różnymi starymi znajomymi albo nowymi znajomymi. I w związku z tym pytanie do Was. Kto znalazł taką inspirację? Kto w tych wszystkich prezentacjach, które dzisiaj widział, zobaczył coś, co mu pomoże w rozwiązaniu bieżących problemów? Rączka w górę. Kto znalazł inspirację? Świetnie, świetnie, bardzo się cieszę. Jeżeli to jest naprawdę fajna inspiracja, a wierzę, że tak jest, to mam do Was prośbę. Podzielcie się ze wszystkimi, żebyśmy, którzy może nie byliśmy na wszystkich prezentacjach, bo nie było to możliwe, wiedzieli, do czego ewentualnie wrócić. Może coś przeoczyliśmy, może zamiast skupić się na prezentacji rozmawialiśmy, czy tu, czy w kuluarach. Co było takiego naprawdę super, na co warto zwrócić uwagę, co Wam pomoże. Bardzo proszę, dołączcie do tej dyskusji, wskażcie te miejsca w tym dniu, które były naprawdę ważne. Kto podniósł rękę? Kto znalazł inspirację? Bardzo proszę, podzielcie się, pomóżcie innym też ją odkryć. Ja wierzę, że te osoby, które jeszcze nie znalazły inspiracji, to znajdą ją albo dzisiaj na piwie o 21:00 zapraszamy na afterparty, albo jutro w ciągu całego dnia konferencyjnego. Marku.
Dziękuję, Dominiku. Dla mnie na pewno inspirujący był poranny wykład pana Waldemara Kota na temat Invoke Dynamic. Były tam przedstawiane aspekty nowości w Javie 7, Invoke Dynamic, która polega na tym, że w skrócie najważniejsza rzecz z tego wykładu, która przynajmniej mnie zainspirowała, jest to, że zamiast wywołania klasy czy instancji jakiegoś interfejsu w danym momencie, mamy wskaźnik na metodę, która jest wywołana i całkowicie zmienia to nasze możliwości w zakresie dynamiczności wywołania funkcjonalności w naszych systemach. Ja osobiście zajmuję się systemami monitorowania i przechwytywania wywołań, więc dla mnie są to jakby nowe możliwości realizowania pewnych funkcjonalności monitorowania, które na pewno w jakiś sposób mogą mi się przydać.
Świetnie, świetnie. Kto jeszcze znalazł jakąś inspirację, chciałby się podzielić? Ja wam powiem, że znalazłem jedną inspirację. Strasznie podoba mi się wykład na temat mówienia historii. Paweł Badeński, The Catcher in the Code. Powinniśmy opowiadać dużo historii. Historie, szczególnie piękne, są budujące. Historie, które opowiada nasz kod, powinny być szczególnie piękne, bo to nasze historie. To my je piszemy od początku do końca, więc życzę wam, żeby te historie, które piszecie, no były warte tego, kim jesteście, a jesteście najwartościowszym elementem naszego społeczeństwa, o którego, jak widzicie, rozbijają się wszyscy pracodawcy. Zapraszam serdecznie i na 21, na afterparty jutro od 9. Będziemy chętnie was gościć. Afterparty jest?
Afterparty jest w Tawie. Adres dokładny miejsca znajdą Państwo w tych małych planerach w agendzie.
Dziękujemy serdecznie za wasze uczestnictwo.